We're starting Unit 8 today. Our new unit is on polygons, and today we're going to focus on the interior and exterior angles of polygons and also how to classify polygons as either convex or concave. So here we go. Let's start off with the definition of polygon. A polygon is a plane. That's not how to spell it. A polygon is a plane figure that meets the following conditions. It is formed by 3 or more segments called sides. We also call these the edges of a polygon, but for our definition we're going to put sides here, such that no two sides with a common endpoint are collinear, and each side intersects exactly two other sides, one at each endpoint. Each endpoint of a side is called a vertex. So let me just sketch one over here so we can make sense of that. Okay, let's see if this is a polygon. It is formed by 3 or more segments. Well, yeah, I got 4 segments here called sides, such that no two sides with a common endpoint. Okay, here are these common endpoints. No two sides with a common endpoint are collinear, and we do meet that criteria here. And each side intersects exactly two other sides, one at each endpoint, and we do see that that's what we have here with this shape that I've drawn. So we know that this is what a polygon is. All right, we'll look at some examples in a few minutes and see what some things that aren't polygons look like too. All right, a blank of a polygon is a segment that connects two non-consecutive vertices. So non-consecutive means they're not side by side, of course. So for instance, this red line that I'm drawing here, that's one of these things I'm talking about. And what are those things called? Those are called diagonals. Any segment that connects two non-consecutive vertices. A polygon with no diagonal having points outside the polygon is defined as a convex polygon. So look at this one that I've drawn up here. Would that be a convex polygon? Do either of these diagonals that I've drawn go outside of the polygon at all? No, they do not. So yes, this is a convex polygon. A blank polygon has at least one diagonal with points outside. That would be what we call a concave polygon. And we have a couple of examples here. So let's see, classify the polygons below as either concave or convex. Okay, concave, we know that one diagonal somewhere is going to have points outside of the polygon. Let's look at this first one here. Let's just draw all the diagonals. Remember, it's got to be a segment between two non-consecutive vertices. So we got quite a few diagonals in here. And there's one, and there's one, and I think that's got them all. Okay, I may not draw all these diagonals. Here's a diagonal, here's a diagonal, there's a diagonal, but look what happens when I draw the diagonal from this vertex to this vertex. Part of it, you see, is outside of the polygon, so this would be a concave polygon. And this one over here would be convex because all the points of the diagonals stay inside the polygon. Okay, what do we call a polygon that has all of its sides congruent? Well, we know it from, we've used this term in reference to triangles. We know that that is called an equilateral. Equilateral polygon. And what did we call a triangle that had all of its angles congruent? Because we're going to call a polygon the same thing. We called that equiangular. And finally, what if we have a polygon that has all of its sides and all of its angles congruent? We just call that a regular polygon. So when you see that term, a regular polygon, you know that that means all of its sides and all of its angles are congruent. Okay, now we got a theorem or two. How do we find the sum of the measures of the interior angles of a convex polygon? And when we say n-gon, we're just saying in general. That means for any polygon, we don't know how many sides it has, but this formula here is going to work for any polygon. So the sum is going to be n minus 2 times 180, where of course n is referring to the number of sides that the polygon has. Okay, and we'll do an example or two or maybe 5 in a few minutes so we can see how this formula works. Well, let's just think about it with respect to a triangle though. Okay, how many sides does a triangle have? A triangle has 3 sides. So if we plug into this formula, then we know the sum of the measures of the interior angles is 3 minus 2 times 180, which is 1 times 180. So we know that's true, right? The sum of the measures of a triangle, interior angles of a triangle are 180 degrees, and so this formula will work with any convex polygon. Okay, now the corollary to this is going to help us to figure out what is the measure of each one of those angles. So the measure of each interior angle of a regular n-gon, now this formula only works if it's regular, meaning that all of its angles, interior angles, and all of its sides are congruent. That's going to be n minus 2 times 180. And then I'm just going to divide it by the number of sides that that polygon has. So there's your formula for the measure of each interior angle. Okay, so here we go. What is the sum of the interior angle measures of a decagon? Well, first I got to remember how many sides does a decagon have. That's going to be a 10-sided polygon, right? So if I want the sum of all the measures of those interior angles, I'm going to use my formula from the theorem that says n minus 2 times 180. So S is going to be 10 minus 2, which is 8, times 180. And let's see, 8, 0, 4, that's 1440. So the sum of the measures of the interior angles of a, not a dodecagon, a decagon is going to be 1,440 degrees. Okay, and then if I wanted to know, if I told you this was a regular decagon and I wanted to know what the measure of each interior angle is, what would you do? You'd just divide that by 10 and you would find that each interior angle measures 144 degrees. Okay, how about this example? What is the measure of each interior angle of a regular pentagon? So first we want to find the sum, right? What is the sum of the interior angles measures of a regular pentagon? Well, it's going to be 5 minus 2, right? So 3 times 180, which is going to give us 540 degrees, and we want to know what each angle measures. So what are we going to do? We're going to divide that by n, which is 5. So 5 into 540 is going to give us 108. So 108 degrees is the measure of each interior angle of a regular pentagon. And if you think about that, what I'm talking about here are each one of these angles, and I can see clearly that it's larger than 90 degrees. So each one of these here is going to be 108 degrees. Okay, how about the exterior angles? That takes care of the interior. How about the exterior? Well, the theorem tells us the sum of the measures of the exterior angles of a convex polygon, one at each vertex, and you can see how we have our exterior angles drawn there, is 360 degrees. It does not matter how many sides your polygon has. The sum of the measures of the exterior angles will always be 360 degrees. Trust me on that. Okay, and the corollary to this theorem says if we want to find the measure of each exterior angle of a regular n-gon, then we're going to do just like we did for the interior measures. The interior angles, we're going to just divide 360 by n to get the measure of each angle. So, for example, if I have a regular hexagon, A hexagon has 6 sides, right? Hexagon has 6 sides, so if I want the measure, I know the sum of the measures is 360, regardless of how many sides the polygon has. If I want to know the measure of each angle, then I'm just going to divide 360 by n, which is 6, and that's going to tell me that each one of those angles on the exterior of the polygon measures 60 degrees. So the hexagon. So let's think about this for a second. Let's look at what a regular hexagon might look like. If you can imagine that this is a regular one. It's not going to be perfect. But anyway, so there it is. There's our regular hexagon. And of course, we're talking about the exterior angles here. So there's that 60-degree angle, right? 60 degree, and each one of the exterior angles will measure 60. And since this is regular, all the interior angles will have the same measure too. So what will the measure of this interior angle right here be? It's going to be 120 degrees, right? 120 degrees. So let's see if our formula would actually give us that. If we want to find the sum of the measures of the interior angles of a hexagon, it's going to be n minus 2, which is 6 minus 2, which is 4. 4 times 180, 0, so 720, right? So then if I want to find what each one measures, the interior angle, I've got to divide that by 6. 6 into 720, it's going to go, 6, 12, 2, 120. So just as I figured, so this little thing that I'm showing you here will come in handy in just a little bit when we start figuring out what individual angle measures are with respect to certain n-gons. So don't forget that little example I just did there for you. Let's see what we have next. Okay, decide whether each of these is a polygon or not. If it isn't, explain why. Clearly, this is a polygon. It meets the 2 criteria that we talked about in the beginning of the lesson. B here, not a polygon. Why is B not a polygon? Because of these little curves. Polygons do not have curves. All the vertices are connected by segments. So, no. Yes. So if you want to write down an explanation, the vertices are not connected by segments. We have curves. We can't have curves. Okay, what about C? C clearly is a polygon. It meets the 2 criteria. How about D? D is a polygon. So how about E? Of course, E is not a polygon because we got this opening right here. Basically, we got a vertex missing. So not a polygon, and then we've got 3 that are. And this one is concave because, as you can see, if I connect this vertex with that one over there, then parts of the diagonal are outside of the polygon. And these 2, A and C, would both be convex polygons. Okay, now what we have here are a bunch of practice problems. So I think maybe what I will do is a few of them, and then, like I typically do, I'll save the rest for you and I'll put the solutions up. So regular. Okay, let's do these. Determine if each polygon is regular. You got to remember, what does regular mean? It means all the sides are congruent and all the interior angles are congruent. This one, clearly not regular, because even though all the sides are congruent, look at this interior angle here. That's larger than 180, isn't it? As opposed to these interior angles. So not regular, and B is not regular. Why? Because these sides are not congruent to the other sides over there. Not regular. And C is regular because all the sides and all the interior angles are congruent. Find the measures of all the interior angles. Okay, well, how many do we have? We've got 4, right? This is a quadrilateral. So what are we going to do? We're going to use our formula. Let's see. Well, we know the sum is going to be 2 times 180. So whenever you got a quadrilateral, the sum of the measures of the interior angles will always be 360. So what we're going to do is we're going to say 118 plus 5x plus 72 plus 3x plus 10 equals 360. And let's see, we'll get 8x equals, and then I'm just going to subtract all the other numbers from the other side. So let's see, we got 360 minus 118 minus 72 minus 10. And I'll come back and put the solution for this up. I'll leave it for you to solve here. 8x equals, we'll come back to that later. If I forget to come back, you can remind me in class. All right, and then this one here, it's a quadrilateral once again, so we got 4x plus 4x plus 2x plus 2x equals 360. So 12x equals 360. So this one's easy. X is going to be 30. 30. So that means these two base angles are 60 degrees each. And these two angles here are 120 each. All right. Find the sum of the measures of the interior angles of a 15-gon. Going to let you do that. Come back and check it. What is the measure of each interior angle of a regular 21-gon? Okay, I'll do this one. Maybe I'll do every other one, and then I'll let you do every other one. Each interior angle, so what do we know? We know that n minus 2 times 180 divided by 21 is going to give us that answer. So that is 19 times 180 divided by 21. Whew, hold on, I got to get my calculator for that. Okay, check me on this. I got about 162.86 degrees. Had to round that off. Double check me. But I do know those angles are going to be really large. The more sides you get on your polygon, the larger the interior angles are going to be. Let's see what's next here. Find the value of x in the diagram. Okay, now we're looking at exterior angles. So let's see, we know the sum is going to be 360 no matter how many sides. So we got 32 plus 2x plus x. This one here is 90. Don't forget that one. Plus 90 plus 2x minus 12 equals 360. So let's see, 2x plus x, 3x, 5x equals 360. And then let's see, we got 32 plus 90. 32 plus 90 is 122 minus 12 is 110. So 5x equals 250. So x equals 50. I think that's it, but go ahead and double check me. And then it says find the measure of each angle. So of course this one's 50 degrees. This one would be 100 degrees. This one would be 100 minus 12, so 88 degrees. And then hopefully when I add all those up, that's going to add up to 360. Double check that. All right, what do we have in this one? We have a regular hexagon. So the exterior angle measures are going to be 360 divided by 6, which is 60 degrees. Let's see. If the exterior angle of a regular polygon measures 12 degrees, how many sides does the polygon have? Ooh, that'll be a good one for you. I'll save that one. What is the measure of each exterior angle of a regular 24-gon? That's another good one for you. I do not want to spoil the fun by doing it for you. And then finally, the rug shown below contains a hexagonal design. 4 of the angles in the hexagon have measures of 150. So that's going to be these. That's going to be those right there. The other 2 angles are congruent. What is the measure of each angle? Well, I know those 4 are 150 each. And if I multiply that by 4, I get 600 degrees, right? What is the sum of the measures of the interior angles of a hexagon? Well, it's going to be 4 times 180, right? Because it's going to be 6 minus 4. I mean, sorry, 6 minus 2. 6 minus 2 times 180. 180 times 4 is 720. So if I already have 600 degrees accounted for in those 4 angles that are marked, I've got 120 degrees left. And I got to split that between these 2 angles. So when I divide that by 2, I'm going to get 60 degrees each for those angles. All right, I'm going to pause now, go back and fill in the other answers that I asked you to work on, and so you come back and check your work. Okay, so if you go back to page 3, you'll see that this problem here was the first one that I started, and then I didn't finish it. And when I did finish all this algebra here, I ended up with x being 20. Oh, but then it says find the measures. Okay, I didn't do that. Well, this is going to be 100. And this will be 3 times 20, which is 60 plus 10, 70 degrees. So there we go. So there are all the interior angle measures. We did the next one. Okay, this one here is the next one that I left for you to do, finding the sum of the measures of the interior angles of a 15-gon or a 15-sided polygon. All I do is use my formula that I learned in the polygon angle sum theorem, 15 minus 2 times 180, and I get 2340. And then I just put this note here for you to help you remember that if this were a regular 15-gon, then each of the interior, if it is regular, each interior angle would measure 156 degrees. And I believe we did the next one. So finally on the next page, I left you 2 there. If the exterior, this one right here, if the exterior angle of a regular polygon measures 12 degrees, how many sides? Well, if I know what the measure is, all I got to do is divide that into 360 because I know 360 is the sum of the measures, and that tells me that that polygon has 30 sides. And finally, what is the measure of each exterior angle of a regular 24-gon? All I got to do is divide 360 by 24. I get 15 degrees. And then my question to you is, using that information, what then is the measure of each interior angle? Okay, well, you don't have to go and say 22 times 180. All you got to do here, and divided by 24, all you got to do is draw yourself a little picture like I have here. If I know that each exterior angle measures 15 degrees, what is the relationship between these 2 angles? What is the relationship? They're a linear pair, right? So it's much easier when you're trying to find, if you have a regular polygon and I ask you to find the measure of each interior angle, it's much easier to find the measure of each exterior angle, and then what do I have to do? I just subtract it from 180 because they're a linear pair. So I find out that each interior angle measures 165 degrees. So that's what I was telling you at the up front in the lesson, not to forget. So I think one of the key things to remember from this lesson is that if you are asked to find the measure of each interior angle of a regular polygon, oftentimes it is easier to find the measure of each exterior angle and then just subtract that from 180. So maybe you could jot that down here somewhere. All right, and we'll see you next time.